Let's have another pressure example. Here we got a half cylinder container. Suppose this is a half cylinder, okay, full of water, and the radius of the semicircle is 1. R equals 1. Okay, and we want the force applying on this side, on this semicircle. Okay, here the force would be the integral of P dA, from something to another thing, but let's do it by the second method I gave you in the previous video, and let's divide the semicircle into infinitesimal parts. Okay, now let's write or draw the infinitesimal part bigger here. Okay, this is our infinitesimal part. Now the force applying on it, the whole force would be the sum of the forces applying on each of such an infinitesimal surface or part. So the force applying on it, or dF, which is infinitesimal itself, equals to rho g h, okay, times dA. This is the pressure of this point, or every point on this, which pressures are the same. And according to the previous video, it doesn't matter which point you are taking, times dA, okay? Pressure times the area. And what is dA? dA here is, is this, the height, say, and what is it? This is this, and this is dH. From this to the top is h, and the infinitesimal part of it, or an infinitesimal change of it, is dH. Okay, so the area dA would be dH over 2 times the sum of these two. And what is the sum of these two? Let's call this from here to here x. This is also x from here to here. Okay, now let's draw these parallel to the blue one. So these two also are x, and that would be dH over 2 times 2x plus the length of this, which is 2x plus this little 2. And what are they? You know, the sum of these two are the change of, or the infinitesimal change of 2x, this is 2x, due to the infinitesimal dh. Okay, so that would be, let me write the rest here, plus d2x, which means the infinitesimal change of 2x. d2x. Okay, and we got, okay. So this is 4x plus this, and now let's multiply this into that and write it here. dA would be this times this, 2x dh, h plus dh, d 2x over 2. Oh, let me write it again. dA okay, let's multiply again. That would be 2x dh plus dh over 2 times d2x. Okay, now here this is an infinitesimal of the second order and ignorable in comparison to this one. And you know, this ignoring thing is not an approximation, but it is exact. It is an exact thing. Like, you know, like what I did with the previous, in the previous video with the area under the curve. And you know, for that, for the infinitesimal part, like this, this, the area of this was an infinitesimal of the first order, and the area of this little triangle was of the second order. And you know, and we ignored it in comparison to this, and the area was this, you know, which is just by the rigorous version of calculus, the limiting things and the Riemann sum things would end up to the same result. So the second order is ignorable,